2.5, scatter plot and linear regression. So this is kind of a new lesson for everyone. So we're going to talk about scatter plots and what they mean, how useful they are, and then we're going to talk about what line regression is and how super helpful that is. So first, it's about scatter plot. It's a set of data whose two variables graph as an ordered pair. So all that means is you're going to get data on something, like they have here actually, right? Then we're visitors to Isle Royale National Park. You can see, like, okay, in 1992 there was about 22,000 visitors. In 2000 there was about 21,000 visitors, and so on. It's just a way to place your data. And you can do it of anything. You could do it for, let's say, how long it takes to get to school, or let's say how far you are from school in miles, to how long it takes to get to school time. Right? In that case, you'd see something where, like, closer you live from school, if you live like down the block, it would take you like hardly any time. But then if you go a little further, maybe you walk to school, so it takes a little longer. Maybe you're so lazy and take the car to school. Maybe a little further, maybe you bike, so it's going to be kind of like this. But you might notice as far as you live out, if you live in Victorville, it could take you forever to get to school. You can get kind of a scatter plot that looks kind of like that, right? Some people drive slower, some people slow faster. But in general, you can get something that looks kind of like that. And that's what scatter plots do. They give you information that talk about two things, and really how they correlate. So there's different types of correlation. There's a positive correlation, which just means that as x goes up, y also increases. So as this goes further out, that goes higher. As you saw right here with our time, right? The further you live from school, the longer it takes you to get to school. It's called a positive correlation. And there's stuff like a negative correlation, like sadly this national park right here. You can kind of see it's kind of a negative correlation. The further out we get, the less people are going to national park. Support national park people. And there's something called a no correlation. That means they have nothing to do with each other. So a good example of that would be, like, let's go back to our how far you live from school. It's about how far you live from school to like your GPA. Right? In that case, it doesn't matter. You might have kids that live really close to school that have really high GPAs or low GPAs. There's like no correlation to that. That's something that has no correlation. It's a random occurrence. So that's correlation. When it's kind of going up, it's kind of positive correlation. As one gets longer or higher, the other one gets higher. And then there's negative correlation as x gets higher, and then y gets shorter. And eventually we're going to talk about strong and weak correlation. And that's about how clustered the dots are together. You might get some that are clustered really close together, it's like a straight line. It's like a strong correlation. And you might get some that look like kind of like these, where it's kind of going down, but it's not like it's super obvious. So strong correlation, weak correlation. So next, talk about, see these little lines here? It's called a line of best fit. So a lot of times when we have a correlation, we try to find a line of best fit. And that's just a line that kind of goes through most of the data. You're trying to get through like kind of the middle of the data. You're not trying to really hit anything, you're just trying to get through the middle of it as best you can. That's what they're doing here. Like, okay, trying to get through the middle. That's a line that best fits. It's trying to get a good approximation of the data sign. Now, there's no one right answer for that. You're just trying to draw a line kind of in the middle. And why is that line important? Well, if you have a line, then if we have a line, we can start predicting stuff. We can write an equation for that. So if we have a line, then we can do a prediction equation. If you have a prediction equation, you can start predicting stuff. You could be like over here. You could go, hey, if I'm moving somewhere new and it's 30 miles away from Alma, how long does it take me to get there? Right? So you use a prediction equation to get a good approximation of stuff like that. Or if you're working at the park service, you're like, oh, in 2016, how many people are going to be at the park? You got to change some stuff. So that's why prediction equation is so important. That's why line of best fit is so important. Now, let's talk about how we're going to do this. So let's say we have our correlation data. Something like that. We're going to draw a line of best fit. Again, you're just trying to get the middle of all the points. You're not trying to hit anything. You're just trying to get kind of through the middle. And then how do I do a prediction equation? Like we do any equation. Y minus y1 equals m times x minus x1, right? That's how you find the equation of a line. So on this prediction equation, you can find two points that cross nicely, like we always do. Find the slope, plug a point in, and we get our prediction equation. That's how it's going to work. So let's do an example here. the table shows the temperature in the ocean at various depths. So if you're right at sea level, it's about 22 degrees Celsius. If you go down 300 meters, it's pretty far. You're at 20 degrees Celsius, and then so on. It gets really cold. Make a scatter plot of a line of best fit. Scatter plot of a line of fit and describe the correlation. So we're gonna do here. Now I'm gonna pause for a second and write this all up. And now I'm back. So I counted my y, my degrees Celsius, by 2. So 2, 4, 6, 8, 10, 12. And I counted my x, my meters, my depth, and by 200. So 200, 400, 600, 800. So try to get a nice tip in my data as best I can. So now I'm just gonna plot it. 0, 22. So 0 at surface level, I'm at surface area. At sea level, I'm at 22 degrees Celsius. And then at 300, I'm at 20. So 300 feet down, it's at 20 degrees. That's the best estimate. And then at 500 feet, meters, I'm at 13 degrees. So 500, 13, that was a big jump. And then at 1,000, I'm at 7. So 1,000, I'm at 7, so around here. And then at 2,000, I'm at 6. So all over here, I'm at 6. So I did my scatter plot. Check that off. Let's go line of best fit. So here's a very important thing with line of best fit, right? There's no right answer. Just trying to draw a line. Now the idea is you're not trying to get a line that hits the most points. You're just trying to get a line that's in the middle of most points, like what's kind of the same distance away from everything. So I'm gonna kind of go like, oof, that is not a good line. But something to that effect. Not my best line. I was trying to go a little higher up, but something to that effect. Oh, I don't like that line. Let me erase it. Do that again. It's hard. I don't have a ruler. So I kind of do like this. But again, no right answer. I could use the last one and been fine. I'm just trying to make a line that kind of goes through stuff. So that's my line of best fit. It would be nice if it's actually straight, but whatever. Describe the correlation. Well, you could look at it, right? Look at your line. It's going down. It's a negative correlation. Later on, we'll talk about strong and weak, but for now, we'll just keep it at negative. So use two-order pairs to write a prediction equation. So next, we gotta find two-order pairs. Now, hopefully, something happens when you draw your prediction lines. You have two places that cross nicely. Like for me, I'm gonna say it crossed nicely right there, and then look for a place where it crosses. Ooh, right here. So I'm gonna use those 2 points. So I'm gonna have 218, and over here I have 1,012. Again, those are just estimates. It all depends on how you draw your line of best fit. But you want to hit two places that cross nicely. That's the goal. So now that my 2 points, let's write a prediction equation, like we always do. Y minus y1 equals m x minus x1. I gotta find my slope, so let's find the slope. Y2 minus y1 over x2 minus x1. Here's, let's say, x1, y1, x2, y2. So I'm going to have 12 minus 18 over 1,000 minus 200. So I get negative 6 over 800. Now, let me actually put the decimal form of that. So let me bring out a calculator real quick. Negative 6, turn it on, negative 6 divided by 800. So negative 0.0075. So that goes here. Now I gotta plug my x1 and my y1. In this case, let's use this. So 200 is my x, 18 is my y. Let's multiply. Now I can just stop there, but I want to simplify so it makes it a little bit easier. So let's distribute that. Negative 0.0075 times 200. Negative 1.5. So that worked out kind of nicely. And that's plus 1.5 actually, double negative. Let's add the 18 to both sides. And I get y equals negative 0.0075x plus 19.5. So that's my prediction equation. So if I want to figure out what the temperature is at different depths, I could plug into that equation. And that's what C says. C says, hey, use a prediction equation to find the missing value. So all I'm going to do is plug that into my calculator. So I'm going to go, okay, negative 0.0075, plug in 2500, so sub that in, plus 19.5. And I get about 0.75. So for me, based on my prediction equation, it's almost 0 degrees at 2,500 feet, 2,500 meters. So that's how I find it, and that's kind of the idea. So that's how you do prediction equation, using data, doing it all by hand. Okay, so next let's talk about more about the regression line and what it means. And then we'll talk about how to do this all on the calculator. Let's skip this for now. So linear regression. So what linear regression is, it's doing it with the calculator. So the way we did it by hand, it's not, if you could probably tell, it's not the most scientific method. There's lots of different answers. So we want to bring some science and technology into this. So what we do is we use a regression line, which is what we use our calculator for, and it does the line of best fit for us and uses complex calculations to find the distance between each point is at the minimum. So on your calculator, let's bring mine up right here. The way we get to that is this. We're going to go stat, calculate, and there's all these regressions right here. So if you scroll down, there's linear, quadratic, cubic. Now we're going to use the linear regression in this one. There's actually more to do with it, but that's how you get to your regressions. And there's actually regressions for lots of different types of lines. So that's a regression line. It uses a calculator to find the line of best fit as best possible. Okay, how about, what's this correlation coefficient? Well, that is the R is how good is your correlation. So when we draw a little line right here, and a line of best fit, we have a line that goes through it, that's have a different R value. Now the way that works is we go from -1 to 0 all the way to 1. 0 is no correlation. So that's when you get like that scatter plots all over the place. So when R is 0, no correlation. When R is 1, that means positive. This is like a perfect positive. That means it's like a straight line. So it's like 100% correlation. Now sometimes we don't get that. Sometimes we have a little bit less, right? It's going like this, but still going up. Then that'll be R like 0.85. The closer to 1 you are, the more positive the correlation is. The stronger the correlation is. So if you get an R that's like 0.3, it's just like weak positive. It's going up, but it's very weak. And likewise when you go other side, when it's like a -1. -1's a super strong negative. It's like a straight line going down, right? But again, if you have ones that are going like kind of like this, that's strong, but it's not like a perfect line. So it might be like a -0.85 or something. So that's what the R does. R tells you how good of a correlation. Now how do you find your R? Well, a couple steps. First on your calculator, let's go to mode. Now if you go toward the bottom, there's all these cool things I'll teach you about later. If you go toward the bottom, there's this thing called stat diagnosis. Now for the life of me, I can't understand why the default is off. So this is how you find your R. So we're going to turn this thing on. So now when we do a linear regression line, when we do one of these, it'll give us an R value, and that'll tell you how strong our correlation is. So the best way to do this is by example. So let's go and do an example. Actually, let's go to the one I skipped up here. Let's do this one. Let's do it on the calculator. So this one says, I can scroll down a bit. The table shows the mean selling price of new privately owned single-family homes for 6 consecutive years. So make a scatter plot of line of best fit and describe the correlation. Okay, so first thing I do is put all this data into my calculator. So we're gonna do that by pressing the stat button first. So here's our stat button. Hit that button, and then you get to edit. Now, and then it brings us to this page right here. So you should have L1, L2, L3. Now, if you're missing one, something could happen. You might have hit delete on accident. If I press delete here, there goes my L1. It's gone now, right? Let's delete L5. Well, there goes L5. So that could happen. So don't ever press delete up here with these values because you lose them all. Now, it's nothing to fear. We can get them back. If I want to get them back, go back to my stat and go all the way to number 5, setup editor. By the way, you can just press number 5. And then we're going to hit enter. Now set your thing up. We'll reset everything basically. So now if you go back to stat edit, all my L1s are back. So now let's go back to actually playing the data. So year, we're gonna let that be L1. So I'm just gonna go and type in 0, 1, 2, 3, 4, 5. I'm going to do the same thing for L2. I'll make L2 the price. I'll put it in 154.5, 166.4, 181.9, 207, 207, 7, there we go, 228.7, and 273.5. So all my data is in there. Now they want to draw a scatter plot. So let's do this. So first thing we do is we can get out of this. Now if you want to draw a scatter plot, well, if you look at your calculator, it says stat plots. Let's hit that. So it's in blue, so I can hit the second button first. It brings us to this page. So I want to go to my plots and I'm going to turn it on. So let's click on the plots. And then see how it's, right now it's dark and off, so it's off. But it's highlighting that, so if I press enter, it switches to on. So now it's on. You go down here, so what type of plot do you want? We want a scatter plot, that's fine. There's all these other ones we'll use later. Scroll down. Do you want your X list to be L1? That's what we had, so yeah, we're good. And your L2 list to be Y, yeah, that's what we had, so we're good. Then this is how, with like what mark you want them to use, so the default's fine. Now we're gonna hit graph, and I see nothing. A couple reasons why I see nothing. One, if you look at my data, it goes from 0 to 5, and then my price here goes from 154 to 273. So this right here is like negative 10 to 10. So I don't see anything right now. If you have a graph here, you might want to, if you go to y equals, there should be nothing there. You can just delete, clear stuff, whatever. But let's get back to this. I want to see my data. There's a couple ways to do it. Way one is fix our window. So right now my window says, if you look at my, it's going to go from negative 10 to 10 and negative 10 to 10 on my y. So for my window here, let's change my x. I want to go from 0 to 5. So I'm just going to hit 0 here for my x pin. That's the lowest x value you want. And the highest x value you want is 5. Scale is what you want to count by. Do you want to go by 1s and 2s? I just always leave it 1. My y min. Now, let's go 0. We could go a lot of things, but I'm going to go 0 here. What's my y max? Well, first I see is 273. So let's go all the way to like 300. Let's round up. Right, the highest one I see is 300. Scale against scale. X-red's like how much resolution do you want? 1's fine. And that's if we're going to leave it alone. Now if you hit graph, yeah, get a little graph looks like that. Right, it's a lot better. Actually, I can see it. So describe the correlation, looks positive to me. It's a positive correlation. If you want me to draw a line, so this goes scatter plot. So I'm just going to, like, it doesn't have to be perfect. Let's just try to match it. It looks something like this. Right, it's kind of going like that. It's kind of going up. It wasn't the best, but it didn't stay on the screen. Let's talk about how to write a prediction equation. By the way, line of best fit, just draw it. That's not a line of best fit, but you know, you just draw it in. Let's do the prediction equation. So for prediction equation, you gotta get out of this. Let's go second quit. Let's go to the regression line I showed you earlier. So we're gonna go stat, calculator, go down to linear regression. Now here it says, do you want the x list to be L1? Yes. Exact same thing we did up there. L2 for a y, yes. Frequency list, that's only if you have a frequency. Now we don't have a frequency here. You'll see, it'll make sense when you see it. So I'll leave that alone. Store requests. We'll talk about this later. Now I'll leave it alone. Let's go to calculate. Right, and then it calculates for you, and then look at what it gives you. It gives you an equation, y equals ax plus b. So that's a linear equation. And it tells you what the values are. A is 23 let's just round it, 23.1, and B is 144. So in this case, it goes 20, I forgot what it was already. 23.1 x plus, I think it was 144 for my B. Right, so that's my prediction equation. Now look at our R there. See how it's 0.97? That's really strong, right? Closer to 1, the stronger you are. So that's a really strong R. It's a really strong correlation. So we have that, my prediction equation. Now let's do the next one. Predict the selling price of a new home in year 8. Well, years were X, so we're just going to plug in 8 here. So we have a calculator. Let's do that, 23.1 times 8 plus 144. So in 8 years, selling price of a home would be $32,328.8 thousand. That's a lot. So that's the way that works. How accurate does your prediction appear to be? Fairly accurate. Remember, RR was huge. RR was like 0.95. It was a solid R. So I'd say it's pretty accurate. So that's how you do. That's how you find the regression equation using your calculator. We'll do a couple more, but just to remind you guys, remember, by hand, you're gonna do a prediction equation. You're gonna plot it by hand, find a line, draw a line best fit as best you can, find 2 points that cross nicely, and then use a point slope equation to find the prediction equation. The calculator, we're gonna type the data into our calculator, and then we'll do a linear regression to find the prediction equation. Let's do another one to practice. Let's another home. Let's go past that. Here we go. The table at the right shows the percent of sales that were made in music stores in the United States in the period of 1999 through 2008. Use a graphing calculator to make a scatter plot of the data, find the graph line regression, and then use a function to predict the sales in 2018. So, same idea. We're going to put all this data into our calculator. So I'm going to go stat, edit. Now, if I want to delete data, a couple of things. So if you want to clear the whole row, just put clear for L1. And that whole column's gone. If you made a mistake on one of the rows, you just put there, you can put delete. And it'll get rid of that one thing. Again, you don't want to put delete up here. If you press delete up here, then it just goes away. You have to do setup editor to get it back. So when you do the whole row, just put clear. Then we're going to type all this stuff back in again. And ta-da. So pause for a second, type them all in there. Remember, you could pause your screen if you want to catch up and type all your stuff in. But I typed it all in, so I didn't want to waste your time. So next, let's do a scatter plot. Now, my scatter plot's actually already on, so I don't have to change anything until already on. You want to make sure you turn it off at some point. I don't see anything, but again, why? Because now my values are all changed. So I could go in my window and make my X-min like 1999, my X-max that 2008. There's actually an easier way. So another way of doing this is if you hit the zoom button. So here's your zoom button. Now if you scroll down to the bottom, there's one that is zoom stat. What that is it zooms to try to fit this as best it can. So let's hit that one, zoom 9. And then it does the graph for you. As you can see in this case, I see it going, that's the negative correlation, it's going down. If they want me to draw it, again, it's a sketch, you don't have to be perfect. Just give me an idea what it looks like. There you go, right? Percent music sales in music stores is going down rapidly. Thank you, iTunes. So there's that. So use the graphic calculator to make a scatter plot. Done. Find a graph and line regression. So let's find a graph and line regression. So for that, we'll go back to our stat. Go to calculator. Let's go to linear regression. Have L1, L2. I don't have a frequency list. That's the only way to say frequency here. Let's talk about store requests. What that is, it's saying store request equation. So they're saying, hey, do you want to plug that equation you find into like your Y so you can graph it? And you don't have to. But if you want to, all you have to do here is put Y1. So it'll plug it into here basically. So it'll plug that equation right there. So I can hit Y1. So how do I do that? Linear regression. Go down there. Now I got to find an equation for that. So the easiest way to do this is you press alpha 3, I believe. Maybe it's, there you go, F4 actually, alpha F4. These are like the shortcut keys. So you bring up F, Y1, Y2, all this stuff. You want to plug in for Y1. So that does, all it's going to do is again, so put that equation we find into Y1. So hit calculate. So there's my equation. X plus B to give me what the A is. It's like negative 1.4. Give me what the B is. And they give me my R. Look at my R this time. Negative 8.4. Not the strong. It's still strong. It's a strong negative. It's not as strong as last time, but still strong negative. Again, I have my equation. Y equals negative 1.4 X plus 2,994. Now remember, let's talk about what each thing means, right? X is sale. X is year. And Y is sales percent. So percent of sales. Now let's talk about what slope means. We haven't talked about this yet. What slope means here. Remember, slope is a ratio, right? So negative 1.4 is y over x, and my y here is sales percent, and my x here is years. So what that's telling me is that every year it's going down another percent. So that's all it says, right? So every year I'm going down negative 1.4 sales percent per year. So just like anytime you see the line, just add a per. Now let's go back to my graph. And see that line there? That's what happens when we put the y1 in. It draws a line of best fit for you so you can see it. Again, not the most important thing in the world, but now you have a line right there. If you go to y equals, that's the equation. They plug it all in for you. Anyway, now they want me to predict the sales in the year 2018. So all we gotta do is sub that in. So y is going to equal negative 1.4 times 2018 plus 2926. Plug that into our calculator. So negative 1.4 2018 plus 2926. And I get about 100%. So I made a mistake somewhere because that is wrong. It should be about 15.4%. I think I rounded it too far, but if you do, I went back and I just plugged in, used the calculator, I got 15.4. And actually, let me show you how I checked my calculator. So this was my graph. Now, one way of doing your calculator, like 2018, is if you press second calculator, it lets you type in a value. Like let's you type in like 2004. And it'll tell you, oh, in 2004 it's 36%. So I wanted to type in, so I went second calculator, 2016. 18, I think it actually was. Now it said error, and the reason it says error is because my window doesn't go down to 2018. If I look at my window, when it goes to 2008. So what I did was I expanded it, so in 2020. So now my graph goes all the way to 2020. So now if I went second calculator and I put value, now I can put 2018, and it gives me about 15.8%. So that's how you do on your calculator. And again, why did my number come wrong? I think because I rounded it way too much. So that all those numbers really affect the score. Anyway, that's the lesson.